now I'm really anonymous. Hi, everybody. Andrew Dolganow. I work now in Nokia, dealing with data center related stuff, but worked for like 25 years in this business. 4 of those years with national security company, building network security stuff. That wasn't a Nokia. And as a result, I'm also talking about security when it comes to our Nokia gear and generally what happens to industry. So if I can get my slides on, I'm assuming they will show up here. Just a quick acknowledgement here to Craig Lobowitz, who heads our deep field business and technology, and a lot of stuff in that presentation is thanks to Craig. I have a. Okay, so a quick one. Cybersecurity is a interesting topic. We all know the attacks come from the network predominantly. The network is this beautiful highway to attack us left and right. Attack us as individuals, attack businesses, attack infrastructure. But how we handle it, how we're making this big red disappear, really depends where you are. And there is really 4 types of organizations. You have your intelligence, highest level of government. Those are the really only guys who really do security. Everybody after, and that may be a shock because defense is in the next one. Everybody after that really is about connectivity, and then how much security they do depends on really how much they care about the perception of security when the impact of an attack happens. Not that green doesn't show up. So, and it goes, from a really secure, then defense, government, critical infrastructure. Okay, we don't want this stuff to really be penetrated, to enterprise, who really, they care about shareholders more than they care about security. And then you and I, who pretend that we care about security, but really don't do much as individuals. So why we're gonna be talking about DDos and how this evolves and what's happening and how bad this makes things? Because the DDos is a massive traffic volume type of an attack, and a lot of the existing security things cannot keep up with the capacity of the pipes we're delivering. So you have to be able to remove as much as possible, as cheaply as possible. Otherwise, the very specialized things that are expensive cannot do their job. And the problems with DDoS are, and its growth and evolution, are multitude. First, IoT. If you look at your basic IoT device, very cheap, firmware never upgraded, so whatever you got is there. It's a beautiful mechanism to launch DDoS attacks. Anybody in this room, if you do not know how to do it, 15 minutes on internet and you can launch DDoS attacks. That's how easy it is. And now, thanks to our service providers, we really have nice pipes to launch a lot of those DDoS attacks. Because, before we had the ADSL, so whatever internet we all had, not much upstream. The more upstream you get, the more single fridge, single switch, smart this, smart that. Everything that's smart, you should think DDoS attacker, a phenomenal source of bot, yeah? And things get bad because the whole remote DDoS really became a weaponized. And we see it, and okay, here's just a few headlines, doesn't matter really which one you pick. The state-sponsored, and by state-sponsored it doesn't necessarily mean national, it also may mean organized crime, is attacking us constantly. There's thousands of attacks daily. Most of them we don't notice because they're not there really to attack us. They really kind of test, if we want to, can we attack you? So every now and then, something happens, and we're seeing results of attacks. But even those are just tests. Those are not really attacks. So coming from a space, again, from the national security, I can tell you pretty reliably, those are just tests. So, but what's going to happen when they're going to become real attacks? Again, we need to kind of figure out how we're going to be protecting internet and infrastructure from those. And the botnets are pretty much becoming the dominant part of how we generate. Taking aside that with number of devices, you can buy a lot of those very cheaply. You can go, you can attack. If you don't like me, you can buy, if you know my IP addresses on some devices, you can do an attack against me for dollars. For dollars. A lot of people sell them. So if you have this kind of experience, what does it mean? And here's an example, and I picked up one that's hopefully not too controversial, but this is an attack against US government. So you would think, hey, those guys protect themselves, yeah? 830 gigs attacked by 31,000 IoT devices from European Union, from Asia predominantly. So it doesn't matter where you are. It doesn't matter where you physically as an attacker, you pick up devices. What did they pick up in this instance? A camera. Very easy. You do a crawling on internet, you can pick up anybody who is most of us are techs here. If you know how to crawl internet, it's doable, not that complicated really. You can discover those devices. Once you discover the device, you can figure out what models they are, what firmware they run. In this particular example, some whatever camera from 2016. If you go look through the model, you can find CVEs. If you find CVE that's newer than the device, you can go to GitHub. You can find the code to explore that. You have now all the pieces to run, to put a bot in place. So now you just need to find those devices, and voila, here is your attack. So that's one problem of DDoS. The second problem of DDoS is Quick. So Quick, a very good protocol. I guess Google guys at some point became really upset with all the networking stuff, how it didn't work with applications. So the nice solution to that was, hey, let's move everything to the application. Let's move the TCP control, let's move the TLS, let's move parts of HTTP. Everything moves into the Quick. Now we in an application space, we can really design applications around any issues in the networks, which is true. But the problem is we made everything in the network look like UDP. And there was a claim, okay, this will be more secure. But there is a difference between security and privacy. Yeah, so what they really have done is made most communication more private. But by doing it more private, not necessarily more secure. It's like your WhatsApp. It's not secure, it's private. It's a big difference. For example, iMessage, not secure, private. That's very big difference between what's secure and what's private. So in Quick, hey, we have built-in encryption from TLS. Great. It can be done on 1.3 and not 1.2.1.1, which anybody with a laptop and 15 minutes on internet can pretty much break. It prevents you from tracking. So as you move, you cannot be linked to the interface. So a lot of capabilities that show on your devices are related to Quick usage. And it's platform OS agnostic, so again, allows much faster development on an application layer and delivery of high capacity, high bandwidth. But like with anything encrypted, as soon as you encrypt everything, it's very easy to sneak stuff under because now it's encrypted. So most of the tools that we use cannot really deal with encryption for proper identification. So you're making a fantastic medium to now deliver malwares and everything else. Because it's an UDP, it can be very easily launched from anything. So you have a larger and larger army of bots and botnets, yeah? And to anything on the network, hey, UDP 443. If you block that, you're blocking internet. So very difficult to kind of work around now. And if you look at the quick, so let's look at the quick, yeah? So this is a server to client response. You look at what's happening on the wire. If you want to kind of use the packets to identify and block DDoS, what can you do with that? Well, you cannot do connection tracking because all you see is UDP 443. Because you're seeing TLS, you can do profiling because you're seeing things related to server name, this blue square from TLS. You can do URL filtering based on that information. If you, in the middle, on the wire, you can do payload-based blocking because you can do inspection as long as it's not encrypted, which it may not be. Huh? The problem with that is it's just too much capacity to do on a reasonable, in a reasonable manner a fully based payload inspection at line rate all the time. Most of the things can change their characteristics. So it's very, if you know how the payload inspection works, a lot of those tools can be worked around with relative ease. So, you can do packet filters, but you need more information. Now, if we look a little bit further, with more and more features added to Quick to give us privacy, well, one of them, with encrypted hellos, will remove everything from, so no more TLS profiling, no more URL filtering, no more payload inspection, really. So now you have really a trouble. And that's why we believe kind of that the packet filtering based on source identification and reputation is pretty much going to be the only truly universal mechanism forward. So it's easy to say how we're going to do this, yeah? So first you need to figure out how the DDoS event takes place. It applies to Quick, but it applies in general, yeah? So the easy indicator is always, massive spike in the traffic. But massive spikes do happen for a valid reason. So on its own, it's not a sufficient condition to look at we have a DDoS. So the next piece is anomaly of traffic. So if you do proper telemetry from your routers, from your network, you have a big data engine analyze what's normal, what's anomaly based on the time of day, based on the sources, destination. You can do this as an additional piece of information. Again, on its own may still not be enough. That's why the key really now comes to understanding who is talking to whom. So knowing the sources of the traffic, because as soon as in your anomaly you see one of those sources that are vulnerable, that they can generate DDoS, you suddenly can extend that information to any new bot sources in the network. So how we do that? Well, continuous source identification. So known the bad actors. There is no easy way to do that, but continuous fingerprinting of the entire internet. If you look at it, every IP address you can crawl. In some countries, you have to be inside. In some countries, you need to know how to go again, across the walls that they built. But it's all about finding the botnets. It's all about finding the booters. It's all about finding IoT devices and then learning what those IoT devices are, and then learning about, hey, if this is your camera, this is the firmware, those are the vulnerabilities. This is the likelihood of that device becoming a source of a botnet in the future. Yeah? And then kind of looking at the traffic that they may be generating, if you can see some of that traffic on kind of on an average basis. And then a lot of, I didn't want to put AI because it's like everybody's using AI. I'm tired with it. Like, pretty soon this will be an AI water. So I didn't use AI, but like it's a lot of machine learning, really training your systems on the information you learn so they can quickly make a decision. The second thing to kind of identifying that is knowing the attacks. So we collect, every vendor does it from security space, but we collect all the information on all the known attacks that we face or our customers face and share with us. So that database, allows us to characterize attacks, characterize the packet sizes. So if a given attack gets repeated somewhere else with similar pattern characteristics, again, we can use it to identification. And then you put this all in the mitigation compile engine, which is trained on both the, here's the IP address, what this IP address is, how likely it is to be source of the DDoS attack. Here is the known DDoS attacks, lots of, magic really happening inside. But fundamentally, if we were to block something like that, what packet ACLs would we use? And then when we see something like that, we can then create a ACL-based protection mechanisms to mitigate the attacks. Yeah? And what kind of match criteria we use depends really on the equipment we talk to. So that's kind of how it looks. Simple. It's relatively simple on the devices, much more complex to kind of make this happen. But hey, here's the rule. We know the protocol usually is easy. There is a prefix of attackers that, once you see the traffic from the routers, and I'll talk about second how we do that before, we can say, hey, this is the port, this is the protocol, this is the attackers, this is something about the packet. Let's say in this simple example, something about the packet length or something about the TTL range. Maybe they're too distant, often a good indication to find the rules. So now, because the botnet attacks become really massive but quick, a lot of botnet attacks last, minute two. They dare to overpower the host. They dare to kind of to overpower the server. They dare to inflict a little bit damage, but do not last too long. Why? Not lasting too long is a little bit of a way of protecting from systems from really defending quickly enough. And if you have those attacks and you have, let's say, botnets, I'm going to send botnet from this 10,000 of devices, and then I'm going to repeat 2 minutes later an attack from this 10,000 devices, or things like that. Or I'm going to randomize the things to make it much more difficult to detect. Yeah. So how are you going to do this? When you do this in the manner like that, it's important how you can detect it and how quickly you can detect stuff. So normally we used to, on our routers, we used to really depend on the net flow type of mechanisms, flow specs. The problem with those mechanisms is that it takes now quite a bit of time to actually deliver the information about the traffic to the mitigation device or to the mitigation engine that then can analyze, is there an attack in place, and what should we do? So if you look at the top path here, if you on average, our customers use NetFlow with 30, 60-second type of timers. If you're using that, that means your first packet of attack can be up to 60 seconds before the system sees it. Then you need to feed it to the engine that can, post-process that information, find out whether the things happen. Well, luckily that's actually heavy optimized, very efficient. So that time of detecting, hey, there is an attack, and we need to put stuff in, it's very quick. But and then you add, hey, now we have to create ACLs, we have to instantiate them on the devices. So that's a net flow spec usually, or netconf. You have to program, do the data path, hey, add 10, 15 seconds on average for a device. We're talking over a minute, really, over 45 seconds, but really over a minute in some cases. So that's not ideal when your attacks last 60, 70 seconds, 80, 90 seconds. Yeah. You're pretty much losing the majority of an attack, and then you have to go and go attack again and go attack again. So that's not necessarily the most efficient. So what we have started to do recently is do really sample port mirroring. Works generally very similar to NetFlow. It's just no cache. And from our systems, we send stuff we need in our mitigation engines to do the, from our routers to do the detection. So now we cut this time of finding the first packet of attack from 30, 60 seconds to 1 second. So nothing else changes, but because we reduce, 30, 60 second delay to a 1 second delay, we shorten the whole time needed to install protection dramatically. So now you can much faster respond to any attack, protecting the servers much, much faster. And now, so that's how and that's this last slide, this is how we kind of put this really all together. Any router, additional information, we can also, depending on the networks we work with, that we can collect. Simple telemetry. The better telemetry, the better. The better telemetry implementation in the routing devices you have, the better, obviously, for the whole solution. And then number 2, this have like pointer. Number 2, there are kind of, if you look, this is the knowing the internet and knowing the bad actors. So I didn't talk about knowing the internet aspects, but pretty much crawling the internet and understanding where is your Facebook, where is your Instagram, where is your Google this, where is your Apple this, and regardless of where they sit in what data center on what part of the world. So feeding that information into our on-prem deployment of the mitigation system, and then as soon as we see the packets based on the information put together, you see real-time both the analytics on what's happening during the attack and the ACLs that are being instantiated and deployed in the network. We deploy this on our gear. Not too many, let me just say, not too many routers can line rate protect DDoS at the proper scale without impact on performance and impact on ACL. So, whatever you have in the network will depend whether you can use your routers that you have, or you need something else, like a scrubbing device that we also deliver, or existing other scrubbing devices or things like that. It is though important, so that's pretty much last slide, but it is important because as I say, there is a lot of, in networking security, there is a lot of, I would say, old thinking. And really when we think of an old security, we really have to, if you remember this first slide, we really have to understand where we are and what money we have, and be very careful how we're spending this money. Because there's too often that I see people buying a certain type of equipment that is very good equipment, but not for a scale that you need. So a lot of capabilities are diminishing when you impacted by the scale of the traffic device needs to handle. So the security is really, what you secure on your peering, it's really about the layering things. Removing things as cheaply as possible, because the attacks are becoming extremely cheap. Yeah, so, and as your peering bandwidth, as your connectivity increases rapidly, it's not that easy to do application layer device at the 100 of gigs type of capacity. So you have to be kind of very cautious to what you put in where, and how you design your security of the network to make sure that you really get money for your dollars spent, and you understand what you're protecting and what you still need to protect. Thank you. So I don't know if there are any questions, I'm happy to answer. But since people want drinks, I'm not going to be offended.
Hi, it's clearly the stupidest guy in the room because I'm the only one that doesn't understand presentations and have questions. Nishal, no hats. A lot of our detection and mitigation systems today are still bound by source or destination, right? How useful is this in a future internet? I mean, we're seeing, much to my disgust, we're seeing like CGN roll out, like it's going out of fashion. And while, of course, you can control the extent of how and what you detect within your network, if I'm looking at something that's one network downstream from me, I used to run a transit network in this country many years ago. If I'm looking downstream at one of my customers who's implementing some kind of CGN, I mean, what are we doing today to detect and what are we going to be doing in the future to detect and deal with attacks that are coming behind CGN type networks?
Yeah, so mitigating, so I say, like, we do believe that you can mitigate with source. It's just understanding what this source really is and what it does. So we're talking CDNs. So as I said, we do a crawling of it on internet to identify bad guys, but also to identify good guys. When we will know a difference between a good guy sending a traffic and suddenly good guy, something that looks like a good guy, sending a traffic that they should never send. Yeah, so that allows us to also detect somebody spoofing the source, which used to be a really dominant way of generating attacks, and suddenly you would see very legitimate source from very legitimate customer sending something that makes no sense. So mitigating, yes, but it's back to really the same goes for your devices. Yeah, there's a lot of apps right now on dealing with where you're connecting, how reliable, how secure, what's the on a scale from 0 to 10, should you connect to that address or should you not connect to that address? It's kind of similar concept. The thing is, the magic really behind this is being able to continuously crawl the entire internet. And it is a massive task to undertake because it's not one location, you need multiple locations, you need to know how to do it. You need to understand how protocol works so you can get the information. You need to have a legal team that every now and then when somebody sends you a letter, why you're doing this and this and this, because we do it openly. We can respond. That's totally legal. There's nothing preventing us from sending this request. So it's all legit, but you need to know how to do this to be legit and to learn the information you need so you can catch based on the information that you have, yeah.
Hendrik Versager from Link Solutions. So the first question that immediately came up to mind is, how is the single website operator going to protect his site from these sort of attacks coming from the internet? Are you looking at something for them, or is it, and in the same sentence, a home user? Are you going to protect them, or is this a sort of solution that will only really be sensible for the bigger persons, the enterprises, those that actually sits in the middle between those website users and the clients?
Yeah, so that's a good question. So there is a majority. Okay, if I go back, can we get the slides back? The last one. Okay, sorry. So I just answered quickly. So the whole system is a software-based solution. Yeah? So you have an on-prem deployment. Now, that can handle whatever needs you have at whatever, and obviously based on that, I don't want to go into commercial, it's a technical discussion. So that's tailored towards any deployment. Then the mitigation, it really depends on what you have in your network. So there's multiple ways that we can mitigate. Our routers, a third-party vendor routers, potentially, maybe you have some scrubbers, maybe we can give you a scrubber for whatever you need, or maybe we can, we also run it in a cloud as a mitigation, but okay, now you need a capacity. So there is no simple answer, but there is multiple capabilities. Hey, there is a lot of colos here that we could work with us and put a deep field as a service solution in South Africa for clients in here as well. Yeah, so it all depends really how you go, but there is options to tailor this. So again,
Andrew,
I'm
sorry, I have to cut you short, but we're running.
I'm happy
to
talk outside of the things for any questions. Thank you, guys.
So, thank you, Andrew.